Alright, in the first part of Lab 2, the first experimental part of Lab 2, we will construct these four circuits and find their Thevenin equivalents. Right, as we introduced last week, we have our analog discovery multi-instrument device and our breadboard to construct the circuits and take measurements with the waveform software. All right. The first circuit is on figure 1A. It's a pretty basic circuit. We need one 680 ohm resistor. Okay, there it is. We are plugging in the resistor. All right, remember that 5 holes along a horizontal line in a column are connected. So we're going to use those. All right, we connected our resistor. Now we will use the DC supply from Analog Discovery. It is the fourth one. The fourth cable from the right. And we are plugging it in. All right. Next, we will plug in our channel so that we can take measurements. We are plugging the first cable from the left, which is the first channel. And we are plugging its negative pole, and we will ground it. Remember that we should always include a ground on our breadboard. Alright, the first circuit is ready. Now we can take our measurements. We are clicking supplies for DC voltage. And we need a 1.5 volts of DC voltage. All right. And now we'll use scope to measure the voltage on channel 1. Right, as expected, it's 1.5 volts, but is it precisely 1.5? Let's see. We can see on the channel C1, C4 channel, C1 column, it's somewhere between 1.49, 1.5. So I guess it's safe to go ahead and record the first experimental voltage as 1.5. All right. Please remember that you are supposed to fill the theoretical voltage column. All right, that's the first circuit. Now let's construct our second circuit. The DC voltage is the same. We are just going to change the resistance values. This time we're going to use two resistors, one 1.2 and one 1K resistor. All right. We're not going to use this one anymore. We need 1K. Let's actually put them here. And 1.2K. And always make sure that the resistor cables are not touching each other. Right. We are plugging our DC supply here. I'm not sure why it's not showing. I'm not sure why the sharpness of the dock cam is this bad, but anyway. So we have our resistors, we have our DC supply, we have our channel and our ground. Now let's enable our DC voltage and again measure the voltage. It's again 1.5, which is also expected, given the circuit. It's pretty much the same, only the resistance value is different. The voltage value is the same. So let's record this as well. All right. Now let's construct our third circuit, the one in figure 1C. Now it will be different than 1.5, right? Because the voltage will be divided across the two resistors. Now let's construct it. Right, we keep our 1K resistor. And we will use a 680 resistor along with it. Yes. All right. Let's put our DC supply here. Connect our 680 resistor and 1K resistor in series. And we need to connect the negative pole of the channel and the ground. With the same row as the 1K resistor. All right, we have our third circuit. All right, now the sharpness is much better. Now we have our third circuit. Now let's measure the equivalent voltage. Again, we are supplying 1.5 volts and we are using scope to Measure the resistance. As expected, the measured voltage is somewhere near 0.898, maybe 89, yeah, 898. Let's record it this way. All right. Now for the last and the most complicated circuit among those four. We need a 1K. All right, we need a 1K, 1.2K, 150K, and 150 and 560 ohms. Right. Let's create our circuit. It's going to be a bit more complicated. And we're going to put, again, let's put them here. Now 1K and 150 should be in parallel. Yeah, I was doing it wrong. All right. And 1.2K and 560K should be in series respectively. Like this. Right, the circuit is ready. Again, we should make sure that the wires are not touching one another. And we are supposed to ground the circuit here, right? Right, we will take the measurements here in this junction. Here and here. All right, that's the fourth circuit, a bit more complex and yeah. All right, let's take the measurement. It's around minus 1.18. All right, so we were constructing the fourth circuit. Now all the resistors are in their right place, and we are taking the measurement at this junction. In the schematic, it corresponds to here, and in the waveforms it's around minus 0.368. So let's record that as well. All right, so what you should do is to calculate the Thevenin and Norton equivalents of all these circuits. Write the theoretical voltages here, find the percentage error, and then explain if there is an error, why that happens, along with the following questions.